rbiostatistics.com video on bootstrapping for numerical data. So bootstrapping is a form of statistical procedure that enables you to create multiple simulated datasets from a single dataset. It's an alternative approach to traditional statistic approaches, but has the same general goal, which is to allow calculation of descriptive and inferential statistics on your data. If you'd like to perform the bootstrapping of numerical data function, you simply go to the rbiostatistics.com website, you select Biostatistics tab, scroll down to descriptive, and then all the way down to Bootstrap Numerical. You then select Analyze, and since I've done that, I will just open this page up. You can select from different file types, and I will select an Excel style file type, and then I'll upload my example data. So this is uploaded nice and quickly, and I'll just talk briefly about what you can see here. So on this right hand side, you can see the data set that I've uploaded, which is comprised of 5 separate groups made of simulated data that isn't real, but you can imagine these to be collected from a sample in a real life experiment. There are a number of tabs up here: Bootstrap Mean, Quartiles, BCA or PERC. I'll talk a bit about those in a second, but just quickly to talk about a few things on the left. If I was using a CSV file format, there are a few other options, but I haven't used that, so I can ignore those. I'll go down to Bootstrap and I select the variable I'm interested in bootstrapping. So I'm going to select variable B. As you can see, nothing updates on this page, but I'm going to move over to Bootstrap Mean. Before I do that, I'll talk briefly about how bootstrapping works. So essentially, a bootstrapping process takes every value within a data set, for example, the data set that I've uploaded, and using random selection, it resamples the same quantity of values into a new simulated data set. Some values from the original set may be selected once, multiple times, or not at all, and the result is a new data set with the same quantity of values, but a slightly differing result. Essentially what you might expect if you went out and repeated the original experiment again. So bootstrapping allows you to perform this resampling process hundreds of thousands of times without having to go out and collect the data again and again and again. The main benefit of bootstrap methods is that they don't require assumptions to be made about the distribution of data, unlike parametric methods. And bootstrapping doesn't rely on a normal distribution. Additionally, due to resampling process, you can generate a larger pool of data without the inconvenience of repeating your experiment, making the assumption that your original data set is representative and of good quality. So I've uploaded my example, and we'll now go across and look at Bootstrap Mean. So the important things to see here is that there are 24 values that it's taken in, and it's performed 2,000 Bootstrap replicates in the time that we uploaded it, and it processed almost instantly, so it's a very quick process. And the important thing to look at is T1, and this is essentially giving us its calculated mean based on 2,000 replications. So this is our mean here. Below it gives us intervals, which are a 95% confidence interval, and you can see this is either normal, basic, or studentized. Unless there are any particular reasons, we would suggest that you either use normal or BCA, which we'll talk about in a second. So this is the mean, and if we go over to the quartiles for BCA, you can see that it presents the data in 25, 50, and 75th percentiles, or quartiles. And these are presented as T1, T2, and T3 respectively. And this gives us our original. You'll notice that I'm ignoring some of the other statistics such as bias and standard error because I don't need to talk about them at this moment in time. And quartiles bases only on 1,000 bootstrap replicas, which again is many times a larger data set than you would have simply if we just run this quartiles on the data set that I produced originally. And it also has intervals below. You may be asking, what's the difference between Bootstrap Quartiles BCA and Bootstrap Quartiles PERC or PERC? So BCA stands for Bias Corrected and Accelerated, whilst PERC refers to Bootstrap Quartiles using percentiles. We would suggest that you use, unless you have a very good reason not to, Bootstrap with bias corrected and accelerated, it takes slightly longer to calculate, but as you've seen, in terms of actual time to calculate on a modern computer, it's very, very rapid and shouldn't really make too much of a difference. So that's everything in this video. And if you have any other questions or things you haven't understood, if you check back on the Bootstrap Numerical page, there is a short frequently asked questions at the bottom, and that may be able to answer any questions you may have. Thanks very much.